Finding a confidence interval for a difference between two means follows a very similar process to everything we've done so far. Our sample statistic now is x1 bar minus x2 bar, and our margin of error is calculated by the formula t star times SE, just like it was for one mean. Only now we're using the standard error formula that we established previously, or we're using the applets to calculate it for us. So we're getting our standard error by a different method, but otherwise our margin of error follows the same basic formula. And t star is a critical value for the t density curve, or the t distribution with n minus 1 degrees of freedom. So we get this from table A. We could also get it from software, but our confidence intervals we usually get from table A because the numbers fall right in the table. So we'll estimate with 90% confidence. We're going down to 90% for this just because our statistical significance was not very strong. So we'll estimate with 90% confidence the difference in mean BMI among smokers and non-smokers in our population of interest. So first, let's recall a few details we already established. First, our x bar for non-smokers minus x bar for smokers was 1.694. Also, our standard error of this difference of means, which we got from the applet, is 0.8370. For a difference between two means, we use the same standard error formula as we used for a hypothesis test. This is not true for proportions. There's that distinction between the pooled proportion and the individual sample proportions. But it is true for means. This is just a simple formula that takes into account the sample sizes and the standard deviations of each sample. So we don't have to look this up a second time. T star we'll get from table A. We need a T star for 42 degrees of freedom. Recall, that's what we found. We'll use 40 because that's close enough in table A. So here in table A, I'll start with the correct column for a 90% confidence interval. Looks like we're in the second data column, and scroll all the way down to 40, and my T star is going to be 1.684. So based on this, my margin of error is equal to T star times my standard error, which is equal to 1.684 times 0.8370. I'll go ahead and round this to 1.418. And now my confidence interval is my sample statistic, which is xn bar minus xy bar, plus or minus my margin of error, which is going to be 1.694 plus or minus 1.418. I'll go ahead and subtract to get the lower bound and add to get the upper bound. I'm going to use my memory buttons for this. 1.694 minus memory recall gets me 0.276, and 1.694 plus memory recall gets me 3.112. So we did manage to get an interval of all positive values by taking a lower confidence level, and we can now interpret this. We have a 90% confidence level that the difference in mean BMI is between these two values. Note that these are both positive, so the whole interval is of positive values. And as we already observed with our hypothesis test, these are actually higher for the non-smokers. We subtracted non-smokers minus smokers and we got all positive values. So that's consistent with what we observed already in our sample statistics, that BMI seems to be higher among non-smokers than smokers by somewhere in this range of values. So here's a possible interpretation of this confidence interval. With 90% confidence, mean BMI, make sure we have the word mean in there. We are really only making a statement about means. We're not making a statement about the whole population or that everybody's going to be in this range. For non-smokers is between these two amounts, 0.276 and 3.112 points. That's our units of BMI. Higher than for smokers. Make sure again that our interpretation of a confidence interval, if it's for a difference of two means or a difference of two proportions, that it makes it clear which is higher than the other. If our interval is consistent like this, it's consistently positive, one of these is consistently higher than the other, we need to make sure that that is clear from our statement.